I think this plane ride is going to take like at least 5 hours. What are you reading? Are you a scientist?
Oh yeah, I'm working on some stuff for my job. I work at Wood Oceanographic Institution.
Oh, cool. It's a great place. I've heard about it. I don't know a lot, but
Yeah, it's pretty cool. I'm actually starting in a new position out in Boulder this fall, though, so I'm pretty excited about that.
that's great.
Yeah.
Boulder's a great place. What are you going to be doing?
So I'll be working with climate models and data to try to recreate the weather over the last 100 years. Since neither models nor observed data can tell the whole story, we're able to produce better estimates of what's actually happening if we combine them. This process of combining data and models is called data assimilation, and a lot of what I've done in the past has been to investigate different techniques to do this accurately.
Oh, well, what's the point of studying something that's already happened?
Well, as you probably know, the climate's been changing recently due to all the carbon that we as a society have been emitting into the atmosphere. In order to better understand how to responsibly manage these changes, we need really accurate models of the climate. So we can use the estimates we get from data assimilation and compare them to real-life observations of what happens in order to validate and verify the climate models we use for prediction. In particular, historical records such as newspapers and diaries can give first-person evidence that a certain weather event happened.
Oh, so you work on improving these models?
That's part of it. The other part is figuring out whether a particular event was extreme or very unlikely or not.
Okay. Well, how do you decide if something's likely or unlikely?
So one way is by using methods which don't just give one estimate of the weather, but rather produce a bunch of different possibilities that represent all the available knowledge. So think about a football game. Before the game has happened, there's a lot of different possible outcomes. You could create a group of these possibilities. So one possibility would be Team A winning by more than 10 points. Another possibility could be Team B winning by more than 10 points, and so on. If Team A's past record is much better than Team B's past record, then in our group of different outcomes, we would see more possible outcomes with Team A winning than Team B winning.
All right, so the possibility of my team like losing is like the possibility of getting rain on the weekend?
Yeah, well, depends whether you live in California or not.
Colorado.
2014 was California's driest year in decades. Los Angeles only got 40% of their average annual precipitation. That's like if Seattle got the amount of precipitation that Denver usually gets.
Yeah. Wow, so then you would use those possibilities to figure out whether an event was likely or not?
Yeah, exactly. Okay. Suppose, for example, that we have newspaper records documenting a rainstorm so intense that it caused flooding during a particular week in the last 150 years.
Mm-hmm.
Now suppose that after combining observations of, say, atmospheric pressure with the output from our weather models, most of the possibilities in our ensemble predicted light rain that week, and a small number predicted very heavy rain. This means that the weather that actually happened, the intense rainstorm, was an extreme event. Continuing this over the weather for the last 150 years will give us a sense of how the frequency of extreme weather events has changed in that time period. We expect to see an increase in frequency of extreme events over the last 50 years as the global temperature has increased.
Okay, so we can look forward to lots of crazy weather then? Is that what you're saying?
Well, climate change is a serious problem, and weird weather is part of its impact. But luckily there's a lot we can do to combat it before it gets worse. The major cause of climate change is the CO2 we release into the air when we burn fossil fuels like coal and gas for energy in our cars. This carbon dioxide builds up in the atmosphere and acts like a blanket that traps heat, thickening as we add more carbon dioxide and warming the earth and disrupting the climate. We expect that the rising global temperatures from climate change will make extreme weather more likely, since rising air and sea temperatures change the atmospheric and the oceanic circulation. In addition, warmer air can hold more water vapor than cooler air, so warmer air temperatures overall can lead to a greater risk of extreme rainfall events. But we can reduce the amount of carbon dioxide we add to the atmosphere in order to address these potential threats and protect the planet from further disruption.
All right, but what can I really do? I mean, I recycle, and I do my best to be environmental, but I mean, a lot of people, I see so many people at work who do nothing. I mean, what's the point?
Yeah. Well, I'm glad you brought that up. Actually, our best bet is to focus on things we can do as a community to reduce our carbon dioxide emissions to make the biggest large-scale impact. So we can do this by reducing the amount of energy coming from fossil fuels, moving towards solar and wind energy, and encouraging our communities to commute to work responsibly. This could be through corporate carpools or collective use of public transportation or bicycling programs. A friend actually recently told me about this Ride in the Rain event in Seattle, which is a competition among teens to see who can bike commute to work the most during November. November is the rainiest month in Seattle. So, yeah. Do you know of anything like that in your community?
Well, there's Ride to Work Day, but it's just one day out of the year. I mean, they do promote biking to work.
Yeah. That's good.
Yeah.
Great. Maybe you can get involved in some of these large-scale things.
Yeah. I mean, I try, but it's always raining. Really, it always rains.
Get the people who motivate.
That
them
is
to
cool
solve
because if you get a lot of people doing it, yeah, that sounds like a great solution.
Yeah.
Yeah, cool. Well, so nice meeting you.
Yeah,
Your
it was
research
nice to meet you
sounds
too.
fascinating.
Thanks.